properties of rational functions. In this section, we're going to talk about domain of rational functions. We have intercepts. We have all different kinds of asymptotes. And we're just going to get into those characteristics of these rational functions. So look at these directions below. It says, for the following exercises, find the domain of the rational functions. Now, this isn't too bad. It's somewhat straightforward. So let's just take number 6. Actually, we'll take 7. So the idea here in number 7, and what we're looking for here is the domain. Domain simply means all possible x values. So the only thing we have to be concerned about is where is x undefined at. And if you look in the denominator, if the denominator turns out to be 0, then we can say that that value is not in the domain of f. That's the only place where my function will be undefined, where the bottom is 0. So essentially to find that, we can just set it equal to 0 and algebraically find out what numbers those are, or number, depending. Okay, so I'm going to add 1 over, so I get x squared equals 1, then I square root both sides, then x equals plus or minus 1. So what we can see here is we can see that, honestly, x cannot equal plus or minus 1 because we were trying to find where the bottom was 0, which means we're trying to find which numbers do not work. So we can say 1 or negative 1. So the way we would write this, we can write this in interval notation. We can go from negative infinity to negative 1, union negative 1, to 1, comma, union from 1 to infinity. So that's how we would write it using interval notation. There's another set builder notation, but I'm going to stick with this for now, just for the simple fact that we'll be doing a lot more with this. So to understand the intervals might be easier for us to graph them. So that's number 7. Let's try another one now. Let's try number 9. So number 9 says my f of x equals, and then we're going to go x squared plus 4x minus 3 over x to the 4th minus 5x squared plus 4. So for this one, I'll have to factor the bottom here, but nonetheless, I would say just the same, x to the 4th, I was going to write squared, x to the 4th minus 5x plus 4 equals 0. And I kind of jumped ahead a little bit because I said I can factor this side. So that's all I'm going to do now. So this is going to be x squared, and I'll say minus 4, x squared minus 1. And those both equal 0. Now, if you work through that, you'll see that that factorization is fine. So again, I know I needed an x squared and an x squared. That gave me my x to the 4th there. And then I also needed a positive 4 here, but I had a negative 5 in the middle, so that's why I had minuses here. And they had to be the same because I got a positive 4. And then just the factors of 4 are 1 and 4. And then when I add those, I'm going to get negative 5. So that's kind of how I worked all that out. Okay, so anyways, now that we have the factors of that, we can say x squared minus 4 equals 0, or x squared minus 1 equals 0. And to solve this, I would move the 4 over, so this is x squared equals 4. And then I square root both sides, so x is going to be plus or minus 2. And then for the other one, move the 1 over, so that's x squared equals 1. And then I square root both sides, x equals plus or minus 1. So now we have the values now. Remember what x cannot equal, because we found out what made the bottom 0. So in turn, we found out what didn't work. So everything else is in the domain but those 4 x values. So the way we would write that is the same way we wrote the other one. Negative infinity to negative 2, union negative 2 to negative 1. Now notice I am going in order with these, so keep that in mind as you go through it. And this is going to be negative 1 to positive 1. And then I got another union there. I'll put it here. And then the last one is going to be No, hang on, I got even one more after that. So that's going to be 1, comma, 2. Okay, and then union 2 to infinity. Whoa, that was a tough one there. So let's see how many numbers we actually had to jump here. It should have been 4. So there's 1. There's 2. There is 3. And there is 4. Yep, so we reached it all. So this would be our answer for the domain of this function. And for the first one, this is the domain of the function here. So we found the answers to those two. Now, just keep in mind here, in order to find the domain, I will have to set the bottom equal to 0 so that I can find out what doesn't work. And I just have to do that for each of those. So that's our first property of rational functions that we're dealing with here.